In this lesson, I'm going to talk about how to calculate the area of a triangle using analytic geometry. So let's say you have a triangle, labeled here ABC, and you'd like to calculate the area of it. Well, most of you remember that the area of a triangle, the formula anyway, is given by base times height divided by 2. Where in this case, this could be my base, and this is my height, where I've explicitly extended this over here. Okay, so in other words, if I had those measurements, then I could use base times height divided by 2, and I'm off to the races. Alternatively, I could use this as my base, and then I could use this as my height. Again, it's going to be at 90-degree angle. So that's an alternate way of calculating it. And if I'm doing it right, it should all give me the same value, because the area after all is just this. So it shouldn't really matter whether I calculate it using the blue base and height or the red base and height. I should really just be able to do it and calculate it and get the same values. So that's kind of what the whole point of doing this with analytic geometry is. It shouldn't make a difference whether you decide to use, for example, the blue base and height or the red base and height. If you calculate them and figure out those lengths and put them into the area formula, you should get the same result. Okay? So let's look at an example of this. Here I've redrawn the same triangle that I had in the last lesson, triangle ABC, and I've used the same points. So before we go ahead and try and calculate the area of this triangle, let's try and figure out a plan. Because after all, we want to have a plan before we start doing all our work, so we won't just be randomly jamming stuff into formulas. So our plan is going to go as follows. We first of all need to choose a base. Now, it doesn't really matter which side we choose to be our base, but we have to choose one side. And just because of the way that I've drawn it, I'm going to choose AB as the base. So we need to figure out the length of, excuse me, I can spell really. We need to find the length of AB. That's our first step, and I think that one won't be too hard. The next thing I need to do is I need to find the equation of AB, the equation of the line AB. And it won't make it, this might seem out of order, but really I need this equation for a later step. So I need to find the equation of AB. All right, in other words, I need to put it into y equals mx plus b form. The third thing that I need to do is I need to find the altitude from C. I need to find the altitude from C. Now that already has that has 3 steps of its own, but really I'm just going to shorten my plan and say altitude. You can look back on the previous lesson to see how we're going to calculate that altitude. The fourth thing that I'm going to do is I'm going to find where does the altitude from C intersect AB. So in other words, I'm going to find the point of intersection between my altitude, between my altitude and AB. Okay? And that POI, that point of intersection, I'll just call P. And then the next to last thing I need to do is I need to find the length of CP. That's really the length of my altitude. And then finally, now that I have both the length of AB and the length of my base, in other words, and the length of CP, which is the length of my altitude or my height, then I can finally put them into the formula, the area formula. Okay? So area using the formula. that's my plan. 6 steps, gosh, and some of them, like step 3 for example, has a few things going on in there. So this is going to be a pretty elaborate plan, and I'll be honest, this is probably one of the most difficult things to properly execute in this course. But you can do it. It just takes a little bit of patience. The first step of my plan is to find the length of line segment AB. And this, if you'll recall, is best done using a t-chart. A lot of things are best done using a t-chart. And I'm going to put in A and B and figure out the first difference. So here it's 10 and here it's 3. And then I'm going to put those numbers into my distance formula. So D equals the square root of 10 squared plus 3 squared, which, if I just leave it in exact form, is the square root of 109. So there you go. That's the length of AB, and I'm done my first step. The second thing I'm going to do is I'm going to calculate the equation, or sorry, not calculate, but determine the equation of line AB. So, in other words, I need to find, if I'm going to write an equation, I need a slope and a point. Right? And I always need a slope and a point, otherwise I really can't get very far. And you can see that because I've already done this stuff in my t-chart, my slope is pretty easy to work out. My slope is just 3 divided by 10. And my point, I have the choice. I need to know a point on the line AB. I can use either A or B. I'm going to use the point 2, 2. In other words, I'm going to use the point A. I take those values and I substitute them into y equals mx plus b. So in other words, y is 2, m is 3 divided by 10, x is 2, and b I don't know yet, but I will in a minute. Give myself a little more room here. So, if I simplify this a little bit, 2 equals 6 divided by 10 plus b. I'm going to subtract 6 over 10 from both sides. So I'm going to have, bring it up there, 2 minus 6 divided by 10 equals b. And in this case, I get 14 divided by 10, or in lowest terms, 7 over 5. So my equation is y equals 3 divided by 10 x plus 7 divided by 5. Okay, that's the equation of AB. Alright, so now I've finished steps 1 and 2. Step 3 of my plan is to find the altitude from the point C. And I went over this in the previous lesson, but if you'll recall, I need to figure out the slope of AB. I need to then find the perpendicular slope to that, and then I need to put that perpendicular slope and the point C into y equals mx plus b, and all that information will give me the altitude. Well, some of this I've already figured out. The slope of AB is 3 divided by 10. That's the slope of AB. So the perpendicular slope to that is going to be negative 10 over 3. And the equation, which will come from using that perpendicular slope and the point C, goes like this. So my y is 10, my slope is negative 10 divided by 3, my x coordinate is 6 plus b, so I have 10 equals negative 20 plus b, so 30 equals b. So I have y equals negative 10 divided by 3x plus 30. Now if I recall, that's the same altitude that I calculated in the last lesson because I used the same points, but it doesn't matter. I wanted to make sure, go through the steps and make sure that this is okay. So now I have the altitude from C, and I'm ready to go on to the next step. Step 4 of our plan was to find the point of intersection between the altitude from C and the line AB. Because they're both in y equals mx plus b form, the most logical strategy is probably to use comparison. So in this case, I'm going to take the altitude from C, the right side, and set that equal to the right side of the line AB. So I have negative 10 over 3x plus 30 equals 3 over 10x plus 7 over 5. Now, if you have Desmos available, you could probably do this in Desmos and find the answer right away. And full disclosure, I've already found the answer using Desmos, but because we haven't done this in a while, it's probably a good idea to try and solve this without using Desmos, right? Just doing it algebraically. So if you've forgotten, follow along here and I'll show you how. So our first step is to get all the constants to one side and all the terms that involve x to the other side. So my next line in my solution will be 30 minus 7 over 5 equals 3 over 10x plus 10 over 3x, like that. Now, the next part will be to simplify the left-hand side, and if I do that, the 30 becomes 150 divided by 5. 150 minus 7 is 143 over 5. On the right-hand side, I need to add 3 over 10 with 10 over 3. And I have to be a little careful. 30 is my lowest common denominator, so I'll have 9 over 30 plus 100 over 30. So I'm going to have 109 over 30 x. And now, of course, I'm tasked with the terrible thing of trying to divide this by this. Well, you know what? They're just numbers. I'm going to end up with a decimal. It's not the end of the world. So I'm just going to zoom out here a little bit. And indeed, I have to pull out a calculator at this point. So I'm going to pull out my calculator, see what happens. And in this case, I will get that x equals approximately 7.872. And my last step is, of course, to take that number and substitute it into one of these two equations. Neither one of them looks particularly fun, so, and I'm going to have to use a calculator for this anyway. So I'll just put it into the second one, and I'll have y equals 3 divided by 10 times this goofy number plus 7 over 5. And if I work it through in my calculator, I get that y is approximately 3.761. And that is verified by Desmos. That is my point of intersection. So I can now say that POY is 7.872, 3.761. Alright, so it's kind of unfortunate that it's such an ugly looking decimal, but that's what we're given, so that's what we gotta do. The fifth step in our plan was to determine the length of CP. So in this case, again, if it helps to stay organized if you use a table of values. So C from the original picture was 610. And we just determined P, which is 7.872 3.872, 3.761. Okay, ugly numbers, but that's why we have calculators. So we're going to put this, so first of all, we're going to realize that here we need to take a difference, and in that case our difference, our delta x, will equal 1.872, and our delta y will equal negative 6.239. I think I did that right. And then we take those numbers and we put them into our, that's delta y. And we take those numbers and we put them into our distance formula, which, as you recall, looks like this. All right. And I won't belabor the point. You basically just put those numbers into your calculator and see what you get. And so in this case, we get that the distance is approximately 6.514 units. Okay? And remember that in our description of our triangle, this whole thing that we've been trying to find, this now is our height. Okay? So we have our height. Now it's on to the last step of our solution. Step 6, calculating the area. So we have the base, and the base was a nice number, which was the square root of 109. And our height was a not so nice number, and it was 6.514. And now that we have those, we're going to put those into our formula. The area of our triangle is base times height divided by 2, or in this case, the square root of 109 multiplied by 6.514, and then divide the result by 2. And in this case, we get, surprisingly enough, almost exactly 34 square units. It's like 34.004, but you know what, I don't care. We're just going to call it 34 square units. So that's it. All of that work to find the area of our triangle. Well, like I said, there's no real parade or no medal for doing all this work, but that's really all the work that we have to do in order to find the area of a triangle using analytic geometry. And as I think I've said to some of you before, this is probably the most complicated thing, or at least the procedure that will require the most number of steps that you'll ever have to do in this course. Alright, so there you go. I'm not going to do another example because these take so long, but my hope is that we'll be able to work through a few of these in class together. I'll see you then. Have a good one.